get used to the nice pictures now because they then go away really fast. Yeah. I have one slide. We're just going to talk through it. I was reminded a little bit, it's kind of like a Monty Python skit, you know, like now for something completely different. We put this talk in towards the end to kind of start to wrap up the symposium and to broaden the discussion a little bit beyond the really sort of focused talks that we've been given today on different aspects of AIM and highlighting different projects. One of the big points with AIM, though, is it's a set of guiding principles that can be applied to any kind of monitoring activity that you do, and that there's value in doing that. And so what I wanted to do with my presentation is just to step you through part of the process that we go through, the sausage making process that we go through in actually developing and implementing one of these AIM projects. We've seen lots of these things today. And so I'm going to kind of go through here a little bit, and I hope this flows nicely because I've redone this a few times today already just based on some of the talks that were given and some of the examples that I wanted to highlight. So I'm going to try to pull from these different talks and try to tie some of these things together a little bit too, and I think Sarah's going to do more of that even. I'm going to speak to it in terms of implementing monitoring. So, you know, we all know, we've all been taught that a good monitoring program has really defined objectives. You have a purpose for why you're out there. You know what you're doing and what the information that you need. There's a lot of planning that goes into it. There's an organized approach to how you're going about that. And, you know, anybody who's been through any kind of process like this knows that it's not necessarily a clean process, and there's a lot of iteration and revision that happens along the way. The AIM principles that we talked about earlier in the day that Emily introduced right at the beginning, these 5 principles of standardized indicators and methods and statistically valid sample design, data management, remote sensing, and it's late in the day and I can't remember number 5. Data. Oh, implementation. That's my whole talk. I'm losing it here. So there's value in those principles relative to the things that we've always been told about for monitoring, right? Adhering to these AIM principles, following these principles, gives us an opportunity to take data sets that we have and reuse them to answer different questions, right? Or it gives us the potential to do that. I don't want to stand here and say that we're always going to be able to reuse data for every purpose, right? But at least we have a base of data that we can start with and that we can pull from, that we can add to. And sorry, that's the end of the pretty pictures. But effective monitoring programs don't just happen, right? There's a lot of work that goes into them, and so we need this sort of planned, structured sort of implementation approach, right? So this model that we've developed over the 4 or 5 years that we've been doing this is adapted from a lot of sort of well-known and well-used sources, the Measuring and Monitoring Plant Population, Cheryl Zinga et al. Book, the original monitoring manual, and I noticed I spelled Jeff's name wrong there. So it's a good thing he's gone already. And so it's a structured approach to the monitoring, but it's also intended to be a little vague so that we have the flexibility that we need to accommodate different objectives, and it's also designed to be an iterative approach. And so this is kind of the basic, you know, the 30,000-foot view of what we do in any of these projects, right? There's a backgrounding phase where we try to take some time, and sometimes this is sort of the painful part of the process, right, where we're trying to pull out all of that basic information that we need to do the design, then the actual design phase of it, then we actually get to the implementation phase. There's a maintenance component for any monitoring program, and then finally at the end we get to actually using the data, right? And then the little sort of dotted arrows here, or the solid arrows, kind of illustrate the fact that we're often going back to earlier parts in the process to sort of change things because they work or revise things as we need to. One of the things I want to really highlight here, though, too, is that what an implementation framework like this does for us is gives us an opportunity to document the process as we go. Because in order to use the data at the end, we have to have the documentation of what decisions we made early on, what the study area was, why we chose the strata we did. So that information becomes important later on, and this gives us a mechanism for actually documenting that. So I'm going to go through kind of each of these bubbles in their sort of gory details. I'll talk about some things. I'm going to give some examples from different projects, and then we'll try to weave it all back together at the end. So the first thing here, step one, is developing our management objectives. This is where we start with any monitoring program. We have to know why we're out there and what it is that we're after. Usually when we start with an AIM project, because we're coming with a set of core indicators to the table, right? The conversation then is about, okay, well, what is it that you need to know that we can't answer with a set of core indicators that we have? Okay, so that's sort of a little bit of a twist, a little bit of a change to that, right? So we look at what are the supplemental indicators that we need. A number of the projects that we've heard today use supplemental indicators. I'm going to actually give some specific examples here in a minute. The step two is to actually figure out what the area is, the area of inference that we have. What are the reporting units? What sort of areas do we need to be able to summarize that information to? And then to develop the specific monitoring objectives from those larger kind of management-based objectives that we start with. And then the third step is we call it selecting the criteria for stratifying the landscape. And I'm going to punt on the stratifying thing for just a couple of slides where I come back to it, because I want to sort of illustrate why we split stratification into two different steps. One of the things that's really helpful or really important for this first phase of our sort of implementation plan is to have a conceptual model. And Scott and Tina in their presentation had a great example of a conceptual model and a lot of thought that went into that conceptual model. And the goal here is to have something that characterizes the different elements of the ecosystem, how they relate, and what the processes are that are influencing those. And from that, and it can be an illustration like this is what we would call sort of a mechanistic or process-based model. It can also be like a state and transition-y kind of model here too, right, which is a box and flow kind of diagram, typical for what you would get like in an ecological site description. And the goal here is to say, okay, I'm interested in preventing, in this case, degraded conditions or sites that are dominated by exotics. And then this will say, okay, well, what causes a transition from one state to that less desired state? And then that helps you identify what your indicators are for your monitoring. Okay, so the conceptual models are a really sort of critical piece to the design and implementation of the monitoring program. So, and I know I just spent just a minute or two on this kind of backgrounding phase. This is actually where we spend almost the bulk of the time in a monitoring program, design monitoring program, is phone calls and meetings to figure out what is it that we're actually going to be out there doing, what is it that we're measuring, how do you need this data, what are you going to do with the data once you get them. Okay, in some respects, the design phase, if we've done a good job in the backgrounding phase, the design phase is actually pretty straightforward. Okay. Here we get from the supplemental indicators that we had, we selected the supplemental methods to go with them. So the indicators are what we're measuring, the methods are how we're actually going to do it. We do some preliminary sample size estimates. We figure out how often we want to go back and remeasure those things, what the size of the change is that we're really looking to be able to measure. We develop our implementation rules. This includes our rejection criteria for when something would be considered to be outside of the population that we would, outside of our target population and a site that we would reject. And then the next step, step 5, is to look at collecting or evaluating some pilot data to evaluate the strata that we have and to look at sampling sufficiency. Now, some projects have a greater requirement for step 5 than others. A lot of the projects in the lower 48 who are working in systems that are fairly well understood, then hopefully have been sort of well described in like a good ecological site description. And we may have some existing data already that we can pull from, and so step 5 kind of runs through pretty quick, okay? Other projects, like Tina presented for the NPRA, we've spent now 3 years on step 5 because, maybe we'd characterize it by we didn't know what we didn't know there when we first got there. And so we've taken a more measured approach of making sure that we understand the system and we know how to sort of collect the information for the indicators that we need, and we know that we have the right strata. And we've made some modifications and some adjustments to that stratification system over the years as a result of the pilot data. Okay. The next step is actually applying the stratification, and I'm going to talk about that next, and then selecting our sampling location. Step 7 is to look at the data QA/QC, and I'm going to push the discussion of step 7 off for just a second too. So, stratification. We split stratification into 2 separate pieces. One that we do in our sort of backgrounding phase is the conceptual side of stratification. What are the processes that are, or the underlying sort of environmental variables that are controlling the expression of our attributes on the ground, right? So figuring out what those are, figuring out if we have to include some other layers for stratification, like maybe some administrative units, because we need to make sure that we have adequate samples, in these different, like allotments or pastures or something like that. And we often have lots of different criteria that we can pick from, and we need to sort of winnow that sort of thing down. So this conceptual phase is very iterative. It's very dynamic. We use a lot of GIS layers and exploration and sort of move things back and forth. The application part in the design phase is actually sort of putting the rubber to the road. We've figured out how we want to stratify the landscape, and then we're actually sort of applying that or implementing that, right? And so at this stage, then we also then calculate our strata areas and figure out what the design weights are for selecting the points. And often we're dealing with situations where our strata layers aren't as great as we want them to be, especially if we're using like soils-based stratification layers. We have issues with, we know it's somewhere in there, but we don't exactly know where, right? And so this is sort of why we split the conceptual part of stratification from the technical side, actually. Supplemental methods, we've gone over this several times today. The core indicators are not intended to answer every question, and you should supplement to get the additional data that you need to answer the questions that you have. 2 examples. Tina gave the example in the North Slope, active layer depth, sort of inserting the probe into the ground and measuring that. Another example, sage grouse habitat assessment framework often does a supplemental height measurement, because the way they've defined heights in the HAP is slightly different than the way the AIM protocol has defined it, although I think that we can reconcile that. The other supplemental piece that they add often is sagebrush shape. So just 2 examples of supplemental indicators that are added. Generally, the cost of adding a supplemental method or indicator is pretty low, because the big cost is actually getting out there to the site in the first place. Here's just a quick example sort of the whole process together for the sample design. This is Zoe's White River Field Office example. She introduced it really pretty well. We had initially a smaller Mesa Verde gas play sort of area was our initial focus. We designed for that. We expanded that study area over the subsequent years to then include ultimately the whole field office. This is just that first initial study area. Stratification was a land potential-based stratification. We didn't have ecological sites to work with, so we worked with old range sites, grouped them together into similar range sites. We used a spatially balanced approach to sample site selection, so it was randomized, but it ensures good distribution of points across the landscape. It's an iterative approach to sampling. So we collected 1 year's worth of data. We looked at the variability of the samples that we got, and then we selected additional samples in strata where we were under sample. And then at the same time, sort of expanding our scope across the field office too. Okay, implementation. Now this is where we actually get on the ground and start collecting. data. The things that I wanted to mention here is implementation. I'm going to get the stop sign, aren't I? Yeah. Okay. Implementation is more than going out and just collecting data. Okay. Implementation starts with good documentation of your protocols and good training of the crews and calibration of the crews that are actually going to be collecting the data. Okay. This is critical to getting good data before people ever go out and collect the data. AIM has put a really big emphasis on quality assessment and quality control of data. This is sort of our basic table that we use for data QA, QC, who's responsible for what levels in the organization it happens, and then what the tasks actually are. And like I said, you know, it starts with training and calibration of your crews. Okay? And it goes all the way through until when the data are actually deposited in the Teradata database at the top. Baseline data evaluation, this happens after the first season of data collection. We just evaluate the data. We look at it in terms of, you know, histograms. We look for outliers. We try to explain sort of weird things that we see in the data. We calculate a set of estimates for our reporting units, you know, as to sort of the status report from that. And partly as a dry run, because it forces us to go through the process of making sure we have all the design information we need to do this down the road. So we have all the stratum weights, we have all the point weights to go with it too. And then we do a sampling sufficiency, make sure we have enough samples to sort of meet our monitoring objectives. The screenshot on the right is a tool that we put together. It's available on the Landscape Toolbox at the website below. You can input data right from DEMA, the DEMA database, into that, and it will do the sample size estimate, sample size calculations for you to help you out with that sort of thing. Okay, maintenance. We need to maintain the monitoring programs we have. They require sort of care and feeding, and this takes the form often of tracking the things that are happening in your landscape over time so that you can explain sort of the covariates to explain the changes that you're seeing. There's also, in a lot of cases, use-based monitoring that has to happen. The monitoring that we do with AIM, by and large, is condition and trend-based monitoring. If there's management decisions to be made off of those data or in tandem with those data, then there's usually a requirement for additional use-based monitoring to go with that. Okay, last thing, step here is actually going back, repeating our monitoring, repeating our sampling, which actually makes monitoring, and then analyzing, implementing, and using the data that we have. Okay, we have a great resource now with Teradata, so the data that are collected at AIM project rolls up into the Teradata database. It can then be sort of distributed back out easily to folks. Doesn't need a lot of extra massaging, and that can be used to sort of synthesize a lot of these basic products we have. They can take the form of maps and sort of indicator summaries by these reporting units of maps that we have. Or it could be graphical sort of representations like Scott showed for the aquatic monitoring stuff today. The important thing in using the data is that we make that link. We figure out what is that framework that actually links the data to the management decisions that we make. And so how do we take indicator values that we maybe calculate at an individual site or plot level or for a reporting unit, and then boil those up and then figure out what are those threshold points that would trigger a management decision or management action. Okay, so here it is all put together. I didn't want to start with this because it would be sort of off-putting, right? But this is the whole process together. The arrows, again, illustrate the iterative nature of this, and I think it's important to use this as a tool to focus on the concepts of the whole process and documenting what we have. Certainly, in implementing this, we make use of all the resources and tools that are available to us, and I would encourage anybody who's designing monitoring programs to do likewise. We're certainly available to answer any questions relative to monitoring in general or AIM in particular. And with that, here's some more sources of information. The Landscape Toolbox website is sort of the go-to spot now for a lot of the documentation. The new edition of the monitoring manual is there at the Landscape Toolbox website. So that's the citation for that is the second bullet. And then I also wanted to sort of point to the BLM Technote 445 because that is the actual publication that describes this modeling or the monitoring process model that I just built for you guys here on the slide. So if that, I will take any questions because I avoided the stop sign.